Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor Space. Before we start, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It'll run for approximately 1 hour with time for questions throughout. I will now turn it over to our speaker for introductions.
Welcome and hello, everybody. Welcome to our series on the Microsoft Fabric and AI Learning Hackathon, where we've been going through all different types of cool technologies that you can use in Microsoft Fabric. And today we are bringing you a topic specifically around AI and Azure SQL database. So today we'll be covering building AI applications with Azure SQL database and Microsoft Fabric. I'm Jasmine Greenaway, and I'm here along with Muazzama Zahid from the Azure SQL team. So if you have any of you out there who use SQL already and have a lot of ideas or have any projects you're working on right now, maybe you're working on the hackathon right now and are using SQL, we'd love to hear from you. And also let us know in the chat what you're working on, where you are, where you're based. To go a little bit in more detail about SQL database and the prize that's available for you if you use Azure SQL database and an AI solution in your project for this hackathon, we're looking at the best SQL and AI integration for this particular category. So there's multiple ways to win. So you have about $1,000 US, as well as social media recognition, as well as being featured on the Microsoft blog post for announcements. So everybody gets to see all your amazing work and everything all the hard work that you've been putting into your hackathon. Okay, so how to be eligible. So we're looking for solutions and submissions that utilize Azure SQL database features. So either mirroring, change data capture technology, which we'll talk a little bit more about later today, or later in this session, as well as using it as a data source that you can use through things like the data factory workload. So what we're looking for is a real-world solution built on Microsoft Fabric that leverages Azure SQL database or SQL Server, augmented by AI capabilities. So using mirrorings, event stream, change data capture connector for Azure SQL database, ingestion using data flows, notebooks, and data factory pipelines, and of course, mixed in with AI-driven analytics and insights. And hello, welcome everybody. I see Paul's here. Welcome. Paul's based in Texas. Jorge, welcome, based in Spain. So let's talk a little bit more about what we'll be covering today in our session. So first, we'll talk about what does AI-ready applications really mean? And essentially, how does Azure SQL Database essentially to power your AI-ready application? So we'll talk a little bit about vector databases. So if you are new to vector databases, you are in the perfect spot. We'll also talk about some open source platforms that you can utilize with Azure SQL Database as well. And then we're going to wrap up with Azure SQL Database and Microsoft Fabric together and the different possibilities there. And throughout the session, you will see a couple of demos. So get excited, get ready. Welcome from India, Chennai, India. Welcome. I can't say your username, but welcome. Thank you for joining us, and share with us again in the chat. And if you have any particular questions, feel free to share that in the chat. And on that note, I'm going to pass it over to Muazzama.
Thank you, Jasmine. Good morning, good evening, good afternoon from wherever you're joining. My name is Muazzama. I am a PM manager in the Azure SQL team, as Jasmine mentioned. I'm super excited to have this session with you to talk about AI-ready applications in Azure SQL database. Put all your questions in the chat. Would love to answer those as we go throughout the session. We would show you some really great demos that we have built with Azure SQL and Microsoft Fabric. And I see people joining from Pittsburgh, Hyderabad, and from USA, Belgium. Thank you for joining. Let's get started. So let's talk about why we're talking about AI. As we see that AI is changing the world, every single day there is a new foundational model coming out. There are companies who are building solutions with AI, but we truly believe that AI is the equalizer and data is the differentiator. Data is the fuel on which AI runs. Garbage in is garbage out. You holding the data in your businesses in terms of databases, in spreadsheets, in the SharePoints of the world, wherever your data is currently stored or in data lakes, we truly believe that you can bring the insights of AI to data. And in terms of Azure SQL database, it is an AI ready database. So we are going to talk a lot about what features you can use, what type of solutions you can build, and I'll give you a lot of examples. Since this is the first session in terms of databases, so I thought we should start with some concepts. So we are all talking about the same things when we talk about AI in terms of vectors, embeddings, vector search, hybrid search, all these terms that you hear these days, and really understand what does it mean. You as an AI developer, what does it mean, right? So there are so many different tools coming out every single day. There are different solutions. So let's think about an application. Let's think ChatGPT as an application. Put it in the chat if you use ChatGPT. I'm sure all of you have used ChatGPT in one way or the other, as is one of the most viral product that came out in the last few years in terms of AI. So let's think you're a developer who's building an application like ChatGPT. What are the needs that you would actually? What are the tools and solutions you need? Starting from the front end, that's the front end that you. What is that you need on the back end, right? Starting from AI tools and developer tools and SDKs, there are so many options out there. These are the ones that you can use in terms of what Azure provides and also the ecosystem in open source such as Semantic Kernel and LangChain. I'll give you an example later today built with semantic kernel. You can build exactly that same solution with LangChain or any of your other favorite tools. Now, when it comes to the tools and SDKs, this is actually for LLMs. You have to use one of the models out there. You can use a GPT model by OpenAI, or you can use an open source model available to you and download it and run it somewhere. Once you have a model, you need to actually have some kind of inference engine, an API to talk to that model. So that's where inferencing endpoints come into being. You can use Azure OpenAI to actually host these models. So again, for this hackathon, we have provided you a proxy from which you can actually start using these models, or you can download it and run it in a solution like Olama. Now, where does this model run? You need capacity, and that capacity comes from the data centers of the world. So in this some case, it could be in my computer. So I have a small model running on my PC, or it could be running in Azure on any of your other solutions that you have access to. And the most important thing here is data, because all of these things in terms of your tools, SDKs, models, all of that, they need data in as an input, and then you can actually build solutions on that. And how you actually build these intelligent solutions with your data is what we are going to talk about today in terms of details. Now, what are the different type of Gen AI use cases that we see today customers building? These is just to give you some ideas of what you want to build using this hackathon, using Azure SQL DB and Fabric. You can build a solution that is chatting with your data to really chat with your data using natural language. You can build an AI assistant or a co-pilot of your own. You can build a document processing solution, content generation, personalization, and the list goes on and on. There's so many different use cases that you can actually start building these solutions for and then go from there. Now, what is needed to actually build the solutions? Vector databases are a backbone for these AI applications. And what is a vector database, right? So the first thing is to understand all these databases that have existed for many, many years, for decades, right? They're really good in storing data and retrieving data. Now, what vectors add the capability to actually store large amount of data in terms of numeric representation of that data that these large language models or small language models understand. And that is the capability that has fundamentally changed how you actually retrieve the data and store this data in these databases. We're going to give you an example of how you can use vectors with Azure SQL database with a quick demo. And then you can actually mirror that data over to Fabric to do a lot of other types of analytics on it. Maybe use a notebook there. And again, Jasmine is going to give you some examples of how to do that as an end to end solution. Now, in terms of understanding how these vectors and embeddings work. Anyone here in the chat can put in the chat, what do you think is an embedding? Let's imagine that you have a word dog, or you have a picture of a dog, or you have a sound of a dog, somebody saying the word dog. Now, these are the three ways you can represent the same data. Now, how do you actually store this data in a way that a model understands that this is a dog? So in traditional machine learning, you use these things called features. And what is a feature? How do you understand a dog is a dog? It is based on the height, the weight, maybe the fur, maybe the breed, all the details that you understand as human that this is a dog. How a dog is different from a cat is how her humans understand these different features and how they represent this data set. Now, for a model like GPT-4o or any of these large language models or small language models to understand the same data, they need to understand in terms of numbers because that's how they are trained on. They understand math. So, to represent a vector for these models, there's a concept called embedding. An embedding is actually an array of numbers. For us, this just looks like a number array. But for these models is how they are understanding the word dog, the picture of the dog, or somebody saying the word dog. Now, it's a very simplified example, but you can imagine complex prompts that you send to these models, and those prompts get transferred into these embeddings, and that embedding is how it understands what do you mean. Now, that's a very simplistic way of defining what is a vector and an embedding. Now, how do you find something is similar? So when you're actually retrieving some data set from a database, you're actually looking for something, you're searching for something. And that's the terminology that we use in terms of vector search. Now, how do you actually define how a dog is similar to a cat, or how similar the two words are, or a few sentences are? So in this example, again, very simplified example on the screen here, dog is definitely more similar to a cat than an apple or a banana. But apple and banana might be closer to each other. So the simplest way to actually find the distances is using, again, some mathematics here. So one of the mathematic formula that you can use is cosine distance. And cosine distance is nothing but difference between two vectors. And there's so many different options to actually try out this. So we support an Azure SQL database, the three most common distance metrics, which include the cosine, dot product, and equilibrium. Now, why do you want to do vector search? You can imagine these large amount of data. If you remember a few minutes back, I talked about vector databases. When you're storing these large amounts of data in terms of text, audio, images, mostly like these graphs, even more complex data sets, you want to retrieve this data most efficiently and for really looking at the needle in the haystack, whatever you're searching for. In the world before vectors, this was always like exact search. So you need to actually search for what you're looking for with the exact text. Now with vector capability, even if you're making spelling mistake from text or your data is not exactly the same, you can use these distance metrics and others to find similar data very efficiently and can really retrieve lot of similar data very fast. And that's what vector search enables you to do with these databases. Now, the distance metrics are talked about. Again, you can read through the slides, all of the material and everything will be available to you. But the top three that we support currently in Azure SQL database are distance, are equilibrium, cosine, and dot product. And you can also use other options for you to actually find out these distances, such as Manhattan distance and others. Now, in terms of why adding vector support in Azure SQL database, we believe that you as a SQL user, SQL is one of the most popular language to retrieve data from databases for decades, and you are really familiar with how to write SQL. So why not bring AI to your data than to bring data to your AI? So really bringing the security, the familiarity, reliability of these systems that we have built for over decades, now bringing AI capabilities directly into the SQL engine is where we think we'll find a lot of customers find value, and a lot of time they don't have to change their entire application to actually build those solutions. These systems are reliable, these systems scale as your data grows, so you can start free, completely free. We have an offer we'll share at the end, which is one free database for the life of your subscription with limits, and you can set it as auto pause when you hit those limits, and you can choose to not get charged for those overages. And with those capabilities, you can build the solution starting from a hackathon to really a production solution to something that you want to do as a project or as something that you want to own in the future as a business owner maybe. So what type of things that you want to? So I already talked about vector search. I'm going to give you a quick example of RAG. RAG is a short form of retrieval augmented generation. This is a great pattern to actually generate data or get data from these LLMs, which is really grounded in your data, the data that you stored in your databases. And again, I'm going to show you a quick example of that. But we also think in terms of relational database, in terms of the databases like Azure SQL database. We provide the best combination to actually do both structured and unstructured. So you can actually look at these documents, PDFs of the world, the large text of the world, but also structured queries. Because when you're really chatting with your data or building a chat application or any kind of application, you're not always just searching for the text part of it. For example, if you have a product database, you're looking for the top products that have these particular things that, let's say, that are good for skiing in the price range of less than $100 or something like that. So that question in natural language can be translated into a natural language to SQL, which can be divided into both structured and unstructured part. For the product matching, you can use the vector search capabilities or the RAG pattern. And for the rest of the SQL, you can use the known predicates such as list price should be greater than $100 and so on and so forth. So that's the beauty of bringing AI to these relational databases. And again, I'm going to show you some examples for that. Now, how do you effectively search these vectors really, really fast? We use an index called DiskKNN at Microsoft. This is the same index which actually powers the Bing engine. It's all open source. The library is up there in the GitHub. It's something for you if you are interested to learn more about. Definitely go check it out. So we are implementing the same DiskKNN based index for vector search, and this will be available soon for Azure SQL DB as well. Now, in terms of showing you how this hybrid search comes into being from relational databases, in this case, Azure SQL database, let's take an example. So this was a great demo that was built by somebody in my team. And what we were talking about is we were going to visit London for a conference, and we were looking for a very specific food. In this case, a focaccia bread. Now, why we chose focaccia bread is because it's easy to find a pizza place, it's easy to find a Thai food place or an Indian food place, but it's very difficult to find something which is very niche and which you only know would be served really well in few places. So as humans, how would you find a best place to eat focaccia bread? You would go to a review of a particular restaurant, and then you'll find which restaurants serve the best focaccia bread. Now, if you are going to a city like London, there are hundreds and thousands of restaurants which can serve that, right? So, as a human, you cannot quickly search that. So, in this example, let's look for the best focaccia bread in town using vector search and the capabilities of Azure SQL database. Now, this is what we have done for many, many years, right? Databases have been known for equality search or inequality search. And SQL database is actually a database which also supports additional multimodal, such as geospatial, regular expressions, and others. So, for example, in this case, if I'm looking for that bread, I will actually look for in London because I'm visiting London. I would be looking for some kind of geospatial, which means a 5 kilometer radius of where I'm staying. You can change the parameters here and change it to 10 kilometers or whatever works for you. Now I know that focaccia bread is served really well in Italian places, so I'm going to search for the Italian press as a regular expression as part of the category column in the table. And then you don't want to just go with any reviews, right? You want to have at least 4-star plus reviews and a place which has enough reviews, because you don't want to go to a place where maybe the friends and family have already provided those reviews. Now, this is what you can do today with databases. So this is nothing new, right? But this does not gives you the best focaccia bread. This gives you a place which might have a good focaccia bread. Now, how do you actually get to that part? Now, I'm looking for the best focaccia bread, and I want to search through natural language saying best focaccia. Now, what you can do is convert the input string, in this case, the natural language word of find me the best focaccia bread, into a thing called embedding, which I just described. And we provide a very basic way of doing it. In SQL, you can use a stored procedure called SP invoke REST endpoint, which can call to any LLM that you have access to through an API, through REST API. And in this case, you will convert the input string into embedding, and then that embedding is stored as a vector in this column called embedding, which you can see at the end of the screen. Now, once I stored this embedding for all the reviews that are there and also the input string, I can use the distance metric to find my input string versus what's stored in the database. And that's what is really the beauty of vector search stored within these relational databases. So now you don't have to search for everything. You really apply the predicates, and predicates are all these filtered. Uh, in London, 5 kilometer, this regex, regular expression, and all of that. Plus, now you can do the semantic search using the power of vectors and embeddings in databases. And let's see this in action. So in this example, I am going to just go back to T-SQL again, using the familiar language that I'm used to. You can do the same thing in Python, C Sharp, JavaScript, any of your favorite language as well. Showing that here in SQL, starting with the query. So basically, this is the data that's stored. I have about 200,000 different businesses and about 9 million reviews. And this is the review I'm really looking for. It's 307305. Remember that ID. And somebody said that this place has the best focaccia that I've eaten in my life, right? So I'm really looking for this particular review. Now here I can use this function called get embeddings that will go to call this text embedding model. That text embedding model converts my input string, a place where to get some good thick focaccia, into numbers or embeddings, and then I can compare this embedding of my search with all the products or all the reviews that are currently stored in my database. And that's what I'm doing here using the vector distance function and using the cosine distance between the input text and the embedding that is stored in the database. I hope the concept is clear. If not, please ask your question in the chat. I'll be happy to do that. Now, this is my regular SQL query, and once I do the search, all I'm doing is order by distance. So I'm finding the top 10 that match my input natural language query. All I did is provide the text, converted an embedding, and you can see everything else is already there: the city, the location, the regular expression, the stars, and number of reviews. So let's run that, and hopefully we can get to the review that we were looking for. So imagine you're searching for this in 8 million plus reviews, and there you have it. 307305 is the most similar one, and that similarity is a distance that it measures between your input text and that. And if you go back, that was the one that you were looking for. So that's the beauty of really using AI with the vector search and embeddings on top of your data. And you can basically apply this to any of your other type of data sets. It could be a product data set, it could be insurance data set, it could be a manufacturing data set. But really, this is the power of bringing vector search into existing databases such as Azure SQL database, where you can apply the filters and then look for the things that you're looking for more efficiently from a large amount of data. This data set is a decent size data. We can actually do this for a very large amount of data as well, very effectively, because again, the query processing engine that we have built for the last few decades is really powerful to understand your intent and really convert into the most optimal plan for your databases. Now, really quickly switching over to RAG. What is RAG? Retrieval Augmented Generation. So imagine the same example that I had. In this case, when I'm searching for the data, I can prompt it further to really ground it on the data sets, really looking for that. So we have in the resources a full hands-on lab example where we use Walmart data as an example, and you can really run through that to see how you can build a solution which is really grounded in your data to do really advanced types of search. If you have questions about this pattern, I'm happy to go into the details after that or answer those questions as well. But the concept here is that you take your input data sets. If they're large enough, you chunk them into pieces. You don't have to chunk them if they're not as large, but ideally you would chunk them if they're large documents or large amount of text. You save them as embeddings, the same concept that we did for the previous demo. But in this case, when you're searching, you do some prompt engineering on top of your data set and ground that in the data that is coming from your database. And in this case, if you're using OpenAI, again, you can use any of these models that you have access to, even the local model. And I have several demos that I've done in the past using a small language model directly on my computer running locally in a container. Now, in order to kind of use these applications, like build these applications end to end, you need some kind of orchestration engine. You need some kind of tooling. So two of my favorite ones that I am going to mention, again, there are many others. I am very well aware that every other day there is a new tool out there to build these kind of frameworks and solutions. You can use LangChain, or you can use Semantic Kernel, which is a Microsoft open source solution. We have a great example with Semantic Kernel. Again, it can be completely built with LangChain as well. These two tools actually provide you a way to very easily connect these vectored sources and really build your orchestration. And a great example for that is this library. So definitely take a screenshot of this, or we have this later in the resources as well. This is a great example where you can build a chatbot literally in like less than an hour. And that chatbot is completely grounded in your data. In this example, we are actually doing using a chatbot on your conference data. You can use any of the data sets that you have access to. It takes few minutes to just install it and run. Definitely try out this sample, get some inspiration from it. And what we are doing in this sample is you're taking the data stored in Azure SQL database. We're using semantic kernel. We have a couple of C# based functions. Again, you can completely do it in LangChain, use Python or any of other programming languages that you're more comfortable with. And then what we're doing here is really looking for the sessions for a particular conference. And we actually provide some memories to the LLM using semantic kernel concept memories. And we provide information about our database in addition to that. And at the end of it, what it does is you can really chat with your database using natural language, find the best session that you want to go in a conference, and really build the solution end to end. Again, it's a great example, great architecture, very simple, very easy to install and ready to go. Again, to give you some inspiration in the world of SQL, what's possible with AI, this is a good example. And again, Jasmine is going to go over some of the examples when it comes to the analytics side of it, how you can mirror this data into Fabric and really build these applications, not just on SQL data, but maybe for other data sources combined together as well. So in terms of the Microsoft Intelligence Data Platform, we have Azure SQL Database is one of the databases out there. You have Microsoft Fabric, and we also provide a bunch of other solutions where you can bring, let's say, Redis plus SQL DB. So you can use Redis in front as cache and then SQL DB as the backend, and then use Microsoft Fabric for the mirroring and analytics part of it. So with that, I would actually hand it over to Jasmine to talk about the Microsoft Fabric part. I'll be here in the chat and answering questions. And over to you, Jasmine.
Thank you, Mosma. So we actually have quite a few questions, and so before I transition on to Fabric, maybe we can just address some of these that we see here.
Sure, let's do that.
So one of the first ones one of the first questions that came up was from Phil. Thanks for your question, Phil. Is a vector database like an old data warehouse? What are your thoughts there?
Yeah, so so to me, there are two types of databases. There are operational databases and there are data warehouses of the world, which are more analytics focused. So Azure SQL Database falls into the first category where it's an operational database. Let's say you have an app. Let's say you have an app like Expedia or e-commerce website or something like that. You want to store your transactional data into a system at a very, very fast pace, a very fast speed. That's where operational these databases are really, really great. So Azure SQL database is one of that. Now vector is just a capability, right? So vector is a capability today available in Azure SQL database, which is an operational database, but it is also available in analytics databases as well. Whichever is your favorite, you can pick, but I'm pretty sure that they are also supporting it. Vector is a capability to actually store these these texts, these audios, and other kind of data more efficiently, and then retrieve it really fast using vector search, right? So to answer your question, vector database is not just data warehouse or operational database. It's a capability, and it's a capability being added to all types of databases. In this case, I showed you example of Azure SQL database.
Great. All right. So we have another question here from Sergey. I don't think the question might be complete, Sergey. So if you could just add a little bit more clarity about the document comparison question you had, we'll definitely address that. So moving on to Vivekananda, they ask, does cosine search or cosine similarity search, does this work fine for all vector databases?
Yeah, it's a great question. So cosine is a mathematical. So I come from math background. My father was a math professor, so really geek out on math sometimes. It's a cosine distance is a very simple way of finding distance between two vectors, right? So the your question is like, is search works fine for vector databases? Yes, it depends on your use case, right? So if your vector is represented in a way that cosine can find the distance, right? Which is the way most of these vector databases support. So yes, cosine should work, but there are other options that I showed in the previous slide: Manhattan distance, dot product, and equilibrium. So you can experiment little bit for your application to see which one works the best for you. But depending on what embedding model you used and how do you store it, in this case for vector databases, a cosine should be the um, most general one that works in most cases. But if you have specific use cases, definitely one of these specialized one would be better. So I'm happy to chat about that in detail because there's some math behind it.
Great. So we also have a comment here from Peter. Peter says, talks about the idea of having a data visualization of vector database embeddings. But before I turn over to you, Moazama, because I want to know if you have any thoughts around like some tooling for that. Peter, if this is something that you think you might be a candidate for something in Microsoft Fabric, we do have a community forum where there are always people are always taking, or the Fabric product team actually looks at any feature request or feature asks from the community. So that might be a spot where you might want to add that in if you think that might be something useful in Fabric. But Muazma, do you know of any tools that kind of do that now?
Yeah, not really in terms of the vector visualizations. There are some tools out there that can actually do visualizations of these LLMs, how these LLMs work. So I can put that in the chat in a few minutes. And I'm not aware of anyone. I would be really intrigued to know why you want to see those numbers, because it's just math, right? So why would you like to see that? Maybe you saw the cosine chart and that's how you want to see. That was oversimplified. It's usually a multi-dimensional vectors, right? So a typical embedding model is like the one that we support is it can support up to 1536 dimensions. So you can't really plot it in a way that a human can really see, but yeah, simplified version of that would be useful. So it's a good feedback. I don't think any tools are out there. I would actually, when the session ends, we'll search for something that is out there.
Yeah. Yeah, they mentioned the GraphRag example in a particular blog post for that project. I'm not familiar with it, but now I'm curious.
Yeah. So GraphRag, if you give me 1 minute to just explain a little bit of that. So GraphRag, so RAG, simple RAG is just using your augmentation of your data and then doing the generation from a model and then retrieving it from your data set, right? Now GraphRag is a technique on top of like a regular RAG where it basically converts your data into graph. You might already have a graph type data set. Maybe you have a um, uh, social media data where people are connected with each other, with friends and all of that, right? Now if you want to search for somebody, the fastest way to actually find somebody is through your connections, right? So if you want to looking for a referral in a company, so the representation of the data in graph and then storing that in the database is the graph rag. Again, in a real world example, those graphs are really complicated. In a very simple example, yes, you can see a visualization, but in real world example, you won't be able to see the real kind of graph of everything that the vector part of it searches for. So, but GraphRig is a great technique, and definitely look into that if you want to, if you have some kind of graph data or you're looking for a graph type relationship.
Great. I learned something new today. Great. So we have some more questions here. This is specifically about the demo you ran, Muazma, the Fakasha demo. So Sergey asked, how does that search that you did, how to understand that London is closer to Brussels than it is to Sydney? And then
Yep.
Peter also asked, what fields did you embed? You just embed the review text, or do you embed multiple fields?
Yeah, very good question. I'll answer the embedding one first. So in this example, we did the embedding on the review text only. I have a few other example in the blog post where we use, let's say, product descriptions and product name and some other attributes together, and then we actually do the embedding on that. So it depends on what you're mostly searching for. In this case, I knew that I would be searching for the text part of it, so that's why the review part of it. So that's why we use that review to be embed. Do make like one caution there is when you are talking to these models, there are token limits, right? So you're charged by the token limits for these models. So if your text is really really large, or review is really really large, or you maybe combine multiple fields, then you really need to go do some kind of chunking and then do that, right? So you have to choose the efficiency versus storage and some kind of trade-offs between them. Going to the other question in terms of London closer to Brussels, is a very good point. So for the models, the text-based models, these language models, right? They understand the distances between languages of how the distance is stored in numbers. As I mentioned, dog is more closer to cat because of the feature set, how dog is represented, and when the model was trained, what features was it trained on, right? Now, in terms of London is closer to Brussels, it if you ask it in a way, in a prompt, that yes, I'm looking for a city near London, then yes, it knows that London is closer to Brussels because it's been trained on the entire map of the world, right? But in your search, when you're looking, that's why I use the geospatial spot there, and that's where geospatial is more exact than the language part of it, right? So if you know already the location, I would go with the predicate for geospatial rather than using a language model to kind of find that what's closer. I hope that answered that question.
Great. Yeah. So we have a couple other questions in the chat, Mwazma. I'll let you answer them while I cover Fabric here. But thank you all so much for your questions. Keep them coming. So I'm going to switch gears here to Microsoft Fabric. For any of you who've already been to any of the sessions in the series, you probably already know what Fabric is, especially if you're already working on a solution. Now, what I'm going to cover specifically in Fabric are the ways that you can essentially interact and bring in Azure SQL Database or SQL Database into Fabric. So there's multiple workloads where you can really start doing this. So first is Data Factory. You can use things like a data flow or a data pipeline and use Azure SQL as your source to bring it in. There's also the data engineering and data science workloads where you can essentially connect to your Azure SQL database, or even a mirrored Azure SQL database to your notebook. The other one is real-time intelligence, and this leverages a technology in databases, specifically Azure SQL, called change data capture technology. This essentially tracks changes to a database over time. And what's so special about real-time intelligence and change data capture is that you can actually see changes in your data in real time. We'll talk a little bit more about that in detail. And finally, OneLake, where you can essentially bring in any data that you might have in your SQL database, mirror that into Microsoft Fabric, and be able to do things like put it in Power BI or do additional analytics to your data. So moving on here, let's go on to the next slide here. So first thing I want to talk about is database mirroring in Fabric. For those of you who are interested, by the way, of some interactions that you can do in Fabric with Data Factory, specifically also using Azure SQL Database in the source, be sure to check the session from last week. I believe that was a week from today, where there was a session covering Data Factory in Fabric in detail. So moving on here, so database mirroring Fabric is a way for you to bring in your existing Azure database, wherever it may be, and our SQL database, wherever it may be, and replicate it into Fabric. So any changes that happen in your database also end up in Fabric in pretty much near real time. And the other cool thing about this is that once your data is brought in, it's actually put into a Delta Parquet format. And the cool thing about that is that any data actually that is brought into Fabrics from any other source, so maybe you mirror another database of a different type, maybe even a different structure, something like something that's JSON based. You can actually query those two databases or query those two sources in Fabric. So essentially, you can do a cross database join within Fabric and actually throw that into something like Power BI or another workload in Fabric. So again, some things that you can do here, cross database querying, like I mentioned before, with shortcuts. You can enhance your ML AI experiences. So for example, if you are using the vector database technology in SQL, you could essentially use that within your notebook and essentially do some more there. And of course, Power BI direct link mode, essentially bringing in your data into Power BI. So let's talk a little bit about the Fabric's real-time intelligence workload. This is, I believe, the newest workload of the bunch here. And essentially the idea that the way that it works is that any data source that you have, you put that essentially into an event stream. This is where their data is captured. Those changes in your data is captured through that change data capture technology, specifically here we're talking about in SQL. That's brought into an event house, essentially, again, capturing these alerts, capturing the important alerts for you, putting that in Reflex, responding to any changes as well. And of course, you can capture that in real time into Power BI as well, as it's all in one lake. So let's talk a little bit more about this change data capture technology. Essentially, the way it works is that your SQL Server or Azure SQL will keep essentially a log of changes in your database. So essentially a transaction log. And so anything like changes, inserts, updates, deletes, and what was changed, changed or updated, inserted, deleted is tracked as well. And so, so over time, you have this set of changes in this separate table. Now, the way that you turn this on is essentially through a simple SQL command. You can do this in for example, SQL Server Management Studio, or even Azure Data Studio, whatever tool you would like. And then you can turn it on, and essentially you're capturing, a history of your data changes over time. Now, one thing I want to just highlight here is that there is change data capture technology, and there also is change capture technology. The difference between the two here is that change data capture has a log of the changes that have been made, including the particular changes in your data. But what change capture does, it only captures that something happened to your particular row, and it didn't capture specifics on what exactly happened. And the key between these two here is that if you need specifics like you would need in something like in real-time intelligence, where you want to kind of see what has happened over time and respond, versus change capture, where maybe you have a little less overhead, right? You're not collecting what changed, you're just collecting that information, that like a log of changes. So that's the main difference there. Change data capture is more focused on what has changed, what changed when and where, and then change capture is focused on the event of something changing. So just something to keep in mind. So essentially, how you would essentially set up change data capture technology, or specifically configuring SQL database in the real-time hub, you would go to the real-time intelligence workload and set up and turn it and connect to your SQL DB. Before you do that, like I mentioned before, to apply change data capture technology, you want to just run a SQL command to do that, and we'll be able to share that in the docs for you to do that. I'd actually recommend that you go through a tutorial and do that as well. Okay, so just a couple of notes here on kind of mirroring versus change data capture. Both of them do read changes from the transaction log. They do look at changes, right? Because mirroring, mirroring has to compare the state between what your database is on particular server, whether that be SQL on-prem or whatnot, as well as what is in Fabric, making that comparison and making those updates as needed. Change data capture, of course, as we've kind of went through already, compares or tracks changes to your data, specifically a table. Mirroring publishes a snapshot of the change data, and change data capture only stores the change data locally in the database. So mirroring, snapshot, change data capture only stores changes. Mirroring supports changes to your database schema seamlessly. So essentially, if like you add another table, or maybe you make do some alterations to your table, that gets captured in there. So no additional configuration that needs to be done there. And then at this point, mirroring is not compatible with CDC enabled or change data capture enabled databases at this moment, but always check the docs to see how things are changing over time. As you all probably know, Fabric is always changing and being enhanced and updated at a really fast clip. So who knows if what changes are on the way. So just be sure to check that. And this is something that you actually want. Like I mentioned before, you can always go to the community, the forum community, and make requests. Okay, so I'm going to show you a couple of demos. The first one I'm going to show you is, let me just open it up here, is using a particular model here in Fabric. So let me just open up my notes here and open up my demo. Okay, great. So FAIS, I say face. I don't know if that's proper, but it stands for the Facebook AI Similarity Search. And the search is a library that allows you to search for embeddings of documents that essentially are similar to each other. Now, without going into any detail, because I can kind of show you this in the blog that we have later in the resources, I'm just going to go ahead and kind of hop into the notebook here. So what I've run here is I don't know if I have my notebook running here, but I'm just going to go ahead and run that here. And while that's running, I'm just going to walk through this notebook here and kind of walk through what I did here. So what we did here is bring in a couple of libraries here. I'm connected to SQL, and I have in my database this table called movie plots. This is actually a data set that we grabbed from Kaggle, and it's very self-prescriptive. We just have some data data of some different movie plots here. We load the sentence transformer model to apply, or to essentially prepare it to convert our data into an index. That's what we're doing here. Essentially we take the text, the title and the plot, and turn that into vectors, again, those multidimensional arrays of numbers. And we create that index, and we actually store that as a physical index or physical file in our lakehouse. So I can open that up and you can kind of see that here. I'm just gonna refresh here, and there we go. There's an index, and then there's our CSV file of our movie plots that we can essentially kind of use for later. So let's go back to our notebook here that's running. And this is still running here, but while this is running, I can kind of give you a little bit of background on kind of just notebooks in Fabric. So this particular demo is actually available in the AI in the SQL AI samples repository. And one thing that I really liked that it was like really easy to upload just an existing notebook in Fabric. So you don't have to like do anything like copy and paste. You can just actually just import your notebook. Another thing that a lot of these notebooks have, or a lot of capabilities notebooks have, is that has a capability to bring in additional libraries that you don't have to like go ahead and install as well. So for example, I believe, and I don't know if this is still the case, but I believe that you have access to some LLMs in the notebook as well. Don't quote me on that, but if someone can share some documentation on notebooks in Fabric. And by the way, if you haven't already, definitely check out the series. In the series, we did do a data science workload session. So definitely check that out as well. So what we did is, so at this point now we're here, we have converted our, we create a function to convert our query text into a vector. And then here we do our search. So here is the query that we said, a high stakes heist in a bustling city. So what if I said something like a romantic comedy, let's put drama at the end. Let's see what's here. This database says quite large, so I'm not sure what's going to return. And there we go. We have a bunch of different titles here, and they all look pretty big here. So romantic drama movie, and that looks like it's like actually at the top here, and you have some comedy as well. So yeah, this is a demo that you can run yourself from the AI, from the Azure, this Azure SQL AI repository. We'll drop that in the chat. And then another thing I just want to quickly just review and show you is how you can set up mirroring in your for SQL. So I can kind of go back here and kind of show you a little bit what I did here. You set up essentially your connection string, you put in your server name, your database name, and then ideally you'll want to set up what is called a managed instance on your database to successfully do this. But once I go ahead and connect to my data source, what I get are some tables here. These tables are actually in the particular database that I want to mirror. Now, so sometimes some of these tables are not compatible with SQL, with mirroring in Fabric. Now, this particular one here, movie plots, when I pulled this in, I didn't have an ID, and neither did I actually give it a primary key. And so the problem here with this particular database, or sorry, this particular table, is that it just doesn't have a primary key. And that is important when you're working with mirrored data here in Fabric. But as you can see, my other self-descriptive table here has movie plots ID. I'll just click connect, and we'll just go ahead and create my mirror database. This might take, this won't take too long, but what you'll see here at this point is that you'll be able to see the changes, or essentially updates on any data that gets pulled in. You can kind of put it on, you can kind of see the schedule of any new updates that happen. And then at this point, you can go ahead and query your data. And so you can see that starting the database is being replicated. And one thing that always, when I first tried mirroring out for the first time, I was like, okay, where do I see the data? How do I get to the data? How do I query the data? And here you go, you can like monitor the replication as well, but I'm not going to step into that. I'm actually going to swap to the SQL Analytics endpoint. And this is exactly where you can query that data. So I can open up, I don't have any queries here right now, but essentially I could open up let's see if I can do this. Open my tables here. The data is still replicating, I believe, so I think it's still being brought in. But either way, without spending too much time here, what I essentially would be able to do is what this essentially pops up is a something like a query table, and I can like essentially just right click on the table or right click on the table. Let me see if it refreshes to see if it's here yet. Not here, but I can just essentially run queries and any other tables that I would have in here or any other data sources I would have in here, anything like else that I mirrored in here would actually show up on the right side here. It wouldn't say, it would just be the name of whatever my the mirror database is. And then I could actually do, this is here where I could do my join and then turn that query, the results of that query into a semantic model and throw that into Power BI. So I actually have a blog post where I did that, and I'll definitely share that at the end here. But that's pretty much everything that I wanted to cover today in Fabric and SQL. So I hope that gave you a lot of inspiration, some ideas on some things that you can incorporate in your existing hackathon project. If you haven't started, that's totally fine. You're the perfect place, perfect time. There's still time. And as Mwazama mentioned earlier, that you can actually just go ahead and create your database, your first or existing Azure SQL database free of charge. You get a lot of compute power, a lot of storage, and of course you can also apply some guardrails on there in case you go over, so that you don't actually get charged. So you can go to aka.ms/SQL free offer to take advantage of that. So this is pretty much all the resources that we have to share with you today. We'll also put these in the chat for you so that you all can take a look yourself. And I'm going to just go ahead and pull up the chat here, see how it's going. And yeah, I think that's it. Wasma, do you have any, did any questions come in specifically around what I talked about today? I was looking specifically at the slides, so I'm
Yeah, I don't see any questions on the Fabric side. I saw a couple of questions I answered in the chat. I can go over that. I think Sergey asked about the accuracy of the vector search. So I mentioned that you have to do some kind of evaluation using a third-party tool such as Ragas. It's an open source tool you can use. There are many others out there, or you can build your own evaluation. You have to choose a kind of top 10 or 20 scenarios. The input text, basically any model that how you train, you have to do train and test, right? So you have to build some kind of evaluation to make sure that your vector search and RAG pattern are providing you the accurate data that you're looking for. And I saw somebody asked, like, can you do a quick recap of embeddings? So we mentioned earlier in there this session that you can probably go back to. It's a numerical representation of your data. The data could be text, audio, video, graph, any type of data. And that numerical understanding of that is multidimensional nature. That is exactly how these models understand that data. And we gave an example of a dog and what that numerical vector would look like. And you can imagine any complex text such as I am taking a dog for a walk, and that sentence will get transferred into converted into numeric representation, and that is basically a numerical vector. So that's the concept of embeddings. And once you store those embeddings as vectors in databases, you can use vector search, or basically vector distance, to find something similar to what you're searching for. So that's the high level concept of vector search. Again, oversimplified, but that's how it works.
great.
Any other questions? Oh, I see a question. Any limitations? Maybe that's for you, Jasmine. Or be aware for using notebooks in AI and Fabric while operation on lower SKU such as F2.
I think the only thing to just be aware of, and by the way, I was doing that demo on a trial subscription actually. So everything that I did there, you can do as well. I think there's really nothing is coming to mind at the moment. Of course, with different SKUs and different workloads, you get a little bit more compute as well. But one thing to also keep in mind is that if you're interested in using any AI capabilities, like if you want to use the Copilot feature within Fabric, specifically within Fabric Notebooks. You will have to, I believe that is the F64 capacity and higher that you'd have to use as well.
Great. I don't see any more questions. We'll definitely reach out to us. We are looking forward to see your submissions. There is a brand new world out there with SQL and AI, and definitely take the advantage of the great features that we showed you today, using the SQL vector capabilities, the vector search capabilities, mirroring, CDC, event streaming. Data factory, any of the above, combining data together. There is a lot of possibilities with this today, and we're looking forward to see what you build.
Right. Thank you all so much.
Thank you.